To get a better understanding of the embedding concept that we just discussed, let's review the embedding model notebook in a repository. We will check the OpenAI embedding model, and then we will take two open source models. For the first one, we'll explore the difference between the input and the output embedding. And then we will try to take some kind of an improved encoder that can learn from the context, and that is very useful if you want to improve our retrieval part. We'll use a rich library to make the input easier to understand, and we'll ignore the warnings. So let's start with the OpenAI embedding. We'll take a sentence. I have no interest in politics, and we call the OpenAI encoder. Note that here we don't have the model here. We have a client. The client is calling the endpoint of OpenAI, and we'll get a long list of numbers. This is the embedding vector of our sentence. Let's dive to the end, and we can see that it's using one of the models, the text embedding 3 small that we chose. It costs us some money of the input tokens, and there was some latency here. The small latency and the small cost is the price we need to pay. But I hope that you understand that if we look again on our diagram, we have the generation model, the LLM that is generating the output once we have all the documents. This can use GPT from OpenAI or Claude from Anthropic or Gemini from Google, but the embedding model doesn't have to be the same one that we have here. There is no relationship between the two. This embedding model that we're focusing now is encoding the documents that we have and calculating the match between the queries of the users and those documents. And once we find this match, we can take the documents and send them to the generation model. So this model and that model don't have to be from the same provider or similar in any way. So this way we're going to use some open source models here, which are open, therefore we can see what they do and learn from their structure and understand better the concept. We will use an open source model from the Hugging Face Hub using the sentence transformer library. We're going to load the model. This model is one of the popular one of the best one. You can go to the hub and check other models there. They will behave quite similarly. Each one of them was trained on different data sets and might meet different requirements, but this one is a quite good one. So the first step is the tokenizer. We have two sentences. I have no interest in politics and the bank's interest rate rises. I chose those two because those are the ones that we had in our visualization a while ago. And we have the same word interest appearing in both of them, but we know that the semantic meaning of each one of the sentences is completely different. And we want to see if the embedding will capture that. We're going to tokenize the first sentence. And we can see that we have, I have no interest in politics, and we have 101, 1045, 2031, and so on. Remember this one, the 3037. This is the word interest that we have in the first sentence. How do I know that? If I run it on the second sentence, I can see that the first one, the 101, is similar, although this is I and this is there. We're going to see in a second what does it mean and how did we get the same token, the same for the last one. But the only one that is similar between the two is the 3037. Therefore, I can guess that this is the word interest. Now we can reverse the process. The input text is translated in tokens, and then the output, when we want to generate a text, we will generate tokens, and the tokens will be translated into words. So this is the process that we are doing here. The second sentence is the bank's interest rate rises. Now we can understand that the first token and the last tokens are control tokens, beginning and end of the sentence, and the rest are the words. We can see that most of the time the words are one-to-one, so the word interest is one token, the same for rate and rises and bank. But the potential apostrophe and the S are different tokens, which makes sense because they change the meaning of the words, and this is what we want from the embedding to happen.